Welcome back in today's session. I am Professor Khaladi from Department of Mechanical Engineering with continuation of previous topic regarding interference in spur gear from unit number 1. This is our third lecture. In previous lecture, we discussed what are those conditions which decides whether interference will occur or not. These two conditions, condition number 1 and condition number 2, were discussed and understand by solving two numericals on the interference. In this session, we are going to discuss the condition number 3, which is minimum number of teeth on pinion and gear to avoid the interference. See, from this formula, on minimum number of teeth, we are finding the value of the teeth on pinion or gear and the value of teeth by the gear ratio formula. If that value will less than the minimum number of teeth, interference will occur. And if the teeth on gear or pinion is greater than the minimum value of teeth, at that time interference does not occur. That thing we have to clearly understand. So the gear is designed in such a way that the teeth on gear or pinion should always greater than the minimum number of teeth, so that interference should not occur in the application, which is the important condition for designing the gear. Okay, now the formula for minimum number of teeth on pinion to avoid the interference is TT, teeth on pinion, and that is minimum number of teeth, is equal to 2 into capital A suffix P divided by under root 1 plus sine square phi into G into in bracket G plus 2. Up to here that term is under root and minus 1 is out of the root. Okay, now the new term AP is introduced in this formula. This is not addendum of pinion. Clearly understand that capital AP is not addendum of pinion. Then what is this? It is the multiplying factor to avoid the interference. Capital AP is multiplying factor which you have to multiply to avoid the interference in this formula. Okay, so what is the value of capital AP? What does it mean? Multiplying factor, how much it should be? So AP is equal to capital AP into M. Small a suffix P is equal to capital A suffix P into a M, where the small AP, small suffix P, small a suffix P is addendum of pinion. Small a suffix P is addendum of pinion, M is module. Okay, now say if the problem statement in the numerical, the statement is like this: if addendum is 1.1 times module, that is given in the problem statement. So addendum is a suffix P is 1.1 module, 1.1 times module. So formula will become here a suffix P, small a suffix P is equal to 1.1 into M. I am comparing these two formula. AP, this one AP is equal to capital AP into M, and this what is given in the question. I have to find out this capital AP. I have to understand this, what is capital AP, what will be the value of capital AP, that I am showing, explain to you. So addendum is 1.1 times module. So addendum of pinion is 1.1 times module. So comparing this and this equation, the value of capital AP will become 1.1. Clear? The value of capital AP, by comparing these two equations, the value of capital AP will become 1.1. Now, for example, in problem statement that is given, if addendum is standard module, in the problem statement, in the data, if it is given like this, addendum is standard module. So addendum of pinion is standard, means one, standard one module. Addendum of pinion is standard, means 1 into module. So comparing these two equation, AP is equal to 1 into module, and this AP, addendum of pinion, is equal to multiplying factor into module. So in this problem statement, the value of capital AP will become 1. Okay. If addendum is standard module, that means value of capital AP will become here 1. And if problem statement is given like this, addendum is 1.1 times module, so capital AP will become 1.1. Is that clear? That is very important to understand what is that multiplying factor, A, capital A suffix P. Okay, and already you know that what is phi, it is a pressure angle, and what is G? G is a velocity ratio or speed ratio or gear ratio. Already in previous session regarding terminology of spur gear, what is velocity ratio? It is the ratio of speed of driver to the speed of driven. Okay. Now second one, minimum number of teeth on gear, TG, teeth on gear, to avoid the interference, is equal to 2 into capital AG. Again it is a multiplying factor, AG, divided by under root 1 plus sine square phi into 1 by G, in bracket multiply by 1 by G plus 2 minus 1. This minus 1 is out of square root. What is the difference between in previous formula, teeth on pinion and teeth of gear? Only difference is that G is replaced by 1 by G. Okay, so that you have to remember while writing the formula in the examination. In formula of minimum number of teeth on gear, only G is replaced by 1 by G. That is a small difference that you have to remember. Okay, again AG is a multiplying factor to avoid interference. And what is the value of AG again? This is discussed in previous slide. Now come to the actual problem to understand this. Two 20-degree involvers per gear have a module of 8 mm, gear ratio 2.5, speed of gear 120 RPM, number of teeth on gear is given 80. The addendum is such that the path of approach and path of recess on each side are 40% of maximum possible length each. That is the difference statement which is given in the problem statement. What is the meaning of this statement? We will discuss in next slide, and which is very important. Okay, now to ask here, determine the addendum for pinion and gear. And second question which is asked here, does the interference occur? This question is asked in examination for 6 marks, and compulsory question is asked in the examination on interference. Okay, now given data is written here. Module 8 mm, pressure angle 520 degree, gear ratio G is given 2.5, and G, number of revolutions of gear, is given 120 rpm. So we have formula to find out angular velocity omega for G is equal to 2 pi n upon 60. 2 pi ng for gear, rpm for gear divided by 60. 2 pi n is given 120 rpm divided by 60. So angular velocity for gear is coming 12.56 radian per second. And next data is given, teeth on gear TG is given 80 numbers. Okay, and to find, we have to find here AP and AG, small AP and small AG, addendum of pinion and addendum of gear. Okay, and secondly, interference occur or not. So before starting the actual numerical, I just explain you what will be the flow of formulas to solve the numericals. Okay, addendum circle radius of gear, that is capital RA for gear. So we are using capital R. Okay, addendum circle. What is addendum circle? Addendum circle is this outermost circle on the teeth. Already we have discussed that, if you remember that. And what is the value of capital RA, addendum circle radius, is teeth circle radius capital R plus addendum for gear. Okay, this is addendum, this is addendum, I'm showing here by above addendum. So teeth circle radius plus addendum is equal to addendum circle radius for gear. Addendum circle radius. Same thing happen in pinion also. This is teeth circle radius for pinion plus addendum of pinion is equal to addendum circle radius for pinion. Okay, so we have to find out AG, AG here, AG, small AG. Okay, small AG. We have to find here what is the value of small AG. This is our first question. Okay, now the value of R we can find out with this formula. We have module formula. Module is equal to ratio of D by T for gear, capital D by capital T. So from this formula we can find out R in this formula. What is the value of RA? RA is addendum circle radius for gear, which is not given. So this is unknown, and this we have to find out. Two unknowns are there, so we can't find out the value of AG here. So first we will find the radius with help of this module formula. Second, in this T is given 80 in the data. Module is given 8 mm in the data. So we can find out with help of that D. Radius, can half of the D is radius. Okay. Now path of approach. In the formula, path of approach already discussed, under root RA square minus R square cos square phi minus R sin phi. Now in this RA, this RA we can put here, RA. Okay, so for that we have to know that path of approach value. What is the length of path of approach? Was it is given directly in the problem statement, it is not given, but indirectly in the problem statement is given. The addendum is such that the path of approach and path of recess on each side are 40% of maximum possible length each. That statement is given in problem. So what is the meaning of that? You have to understand clearly. Without understanding this meaning of that statement, you can't solve the numerical. Okay, path of approach. Now listen here. path of approach are 40% of maximum possible length. What is path of approach? PF. This is path of approach. This path of approach PF is 40%. That means 0.4 into maximum possible length. What is maximum possible length? PB. Maximum possible length of path of approach is PB, and after that interference will occur. Up to B, interference does not occur. So maximum possible length of path of approach is PB. Okay, so PF, path of approach, is 40% of maximum possible length of path of approach, PB. So in numerical, I am writing that statement PF is equal to 0.4 into PB. Same thing happen in path of recess also. In path of recess, EP is 40% of maximum possible length. EP is 40% of maximum possible length. What is maximum possible length? To avoid the interference is AP. Okay, so A and B is point of interference. Beyond that, interference will occur. So this is AP. This AP is maximum possible length to avoid the interference. So as per problem statement, EP will become 0.4 into AP, maximum possible length of path of recess. Okay, so PF we can find out in 0.4 into PB. But what is PB? What is PB here? PB. So in the derivation of length of path of contact, PB will become PB. We have to find out, but O1P, which is small r, this circle radius is given. We have r, we have pressure angle phi. So PB, as per trigonometric rule, PB will become here r, small r sin phi. This is small r. I'm considering this triangle O1BP, O1BP. Okay, O1BP. The value of PB I'm writing in terms of r. Why r? Because this circle radius of pinion is given, or we can find out by module formula. Okay, so PB is equal to r sin phi, and AP, same thing. AP is capital R sin phi. Again, I am applying trigonometric rule. This triangle I am considering O2AP. O2AP. So AP is equal to capital R into sin phi. Capital R into sin phi. Okay. So for understanding the problems or for solving the problems on interference, you have to clearly remember this figure. Clearly understand, and we have to clearly remember this figure in the examination also. Okay, so these are we can find out by model formula d by t. Okay, so m we know, again t is unknown. Two unknown have said, d is unknown, t is unknown. So to find out t, gear ratio is given 2.5. Okay, what is gear ratio? Speed of driver to the speed of driver, or diameter of driven wheel to the diameter of driver wheel, or gear ratio is equal to number of teeth on driven wheel to the number of teeth on driver wheel. So I am considering this ratio, this value is given, this number of teeth on gear is given, two values are known, only T1, teeth on pinion, we have to find out. Okay, so this is the flow to solve the numericals. Gear ratio we can T1 you will find out, put the value of T1 here. So D will find out, put the value of R in this equation. So PB will find out. So put the value of PB here. So PF will find out, and if put the value of PF. This is known. This is known. Capital R is known. Phi we known. Okay. Only we have to find out RA. Only one factor is unknown, so we can find out RA. If we put the value of RA here, this is known. Capital R is known. Only one factor is unknown, AG, which is to be find out. So putting the values of RA and R, we can find out addendum of gear. Okay, this will be the flow to find out the value of AT and AG. Now come to our actual numerical. Given data, gear ratio, one by one gear ratio. In the viewers procedure, I am start solving the numerical gear ratio, and after that D, after PB, and after that PF. Okay, in the viewers procedure. So first I am finding the value of teeth on pinion. Okay, gear ratio is T2 by T1. T2 is given 80 divided by teeth on pinion, which we have to find out is equal to gear ratio 2.5. So value of teeth on pinion is getting is 32. Okay, 80 divided by 2.5 is equal to teeth on pinion is 32. Second thing, teeth circle radius for pinion. Teeth circle radius for pinion. This formula. After getting TP, I am putting TP here. Okay, to find out small d and small r. This circle radius for pinion module is given 8 mm. Number of teeth we got here 32. So d by cross multiplication 8 into 32 is small d is we are getting here 256. When d is 256, radius, the circle radius of that diameter is half of 256 is 128 mm. 128 mm is the value of small r, which is p circle radius. Now p circle radius for gear, again we have module formula, m is equal to capital D by capital T. So value of capital T is given 80 mm here. Okay, module is given 8 mm. Okay, so value of D is by cross multiply 8 into 80 is 640 mm. When diameter is 640 mm, radius of pitch circle radius for gear we are getting half of 640 is 320 mm. Okay, now putting the value of small r in PB. Again I show putting the value of PB in this formula. Okay, PB. So PB is equal to small r sin phi. Small r is 120, sin 20 is equal to 43.77. Okay, PB. PB we receive here. That PB will fit in this equation to find out PF, which is path of approach. Okay, so PB is 43.77 into 40% of maximum possible length. 40% 0.4 into 43.77. So path of approach PF we are getting here 17.51 mm. Okay, path of approach. So this is the formula. Now this value 17.51 we are putting in this equation. 17.51 RA we have to find out. R we have already find out 320. Value of pressure angle is given 20 degree. So only one unknown is there. So by solving this equation, we are getting value of capital RA. Capital RA. Okay, is equal to 326.44. What is that RA? Addendum circle radius for gear. Capital R is for gear. Addendum circle radius 326.40. Okay. Now addendum circle radius is getting 326.40 is equal to each circle radius and plus addendum for gear, which is to be find out. So 326.40 minus 320. So value of Addendum for gear we are getting here 6.40 mm. Okay. Now we have to find out next thing, addendum of pinion. The same thing we are following here also. AP is equal to capital R sin phi, 320 into sine of ratio angle, getting here 109.44 mm. So EP, path of recess, is equal to 40% of maximum possible length. 40% of maximum possible length is 0.4 into AP 109.44 is equal to 43.77. This is path of recess. Okay, so path of recess value of this known. This we have to find out. Okay, this known and this known. Only one RA, small RA, is unknown. So putting the value of path of recess in this equation, we are getting small r suffix a, addendum circle radius for pinion, small r, that means that is a pinion, is equal to 148.77. So addendum circle radius of pinion is 148.77 is equal to small ra, we got here 128 plus addendum of pinion. So addendum of pinion is equal to 148.77 minus 128. So we are getting here 20.77. This is addendum for pinion. Clear? Now again, in some numerical in examination, if that is given, the addendum is such that the path of approach and path of recess is half the maximum possible length. Half, if in the examination, second case I am discussing here, if that is given, the addendum is such that the path of approach and path of recess on each side are half the maximum possible length. At that time, PF is equal to 1 by 2 into PB will become here. Half, 1 by 2. Instead of 40%, that will come half. If in the examination it is given, the addendum is such that the path of approach and path of recess is 3 by 4 times of maximum possible length. 3 by 4. So PF is equal to 3 by 4 into PB. EP is equal to 3 by 4 into maximum possible length. Clear? That things you have to clearly understand while solving the numericals. Different cases will ask in the examination half the maximum possible length, 3/4 of the maximum possible length. At that time, this value only will change here. Other numerical will be same. Okay. Now the second thing which is asked in the numerical is minimum number of teeth on pinion to avoid the interference. So this is the formula. So putting the values of AP is not given, but we have find out small AP is equal to capital AP into M. We have that formula. Okay. So small AP we got here 20.77. This is 20.77 random of pinion. Okay, is multiplying factor into M. Although it is given. So 20.77 into AP is equal to AP into 8 module. So value of AP is getting here 2.5962. Okay. Now putting the values of AP here, ratio angle we know, speed ratio G already given in the question, that is 2.5. Okay, all values are known, only PP we have to find out. So putting the values of AP, phi and G in above equation, we got value of TP. By solving this equation, TP is equal to 9.952, which is equal to 10. Why 10? Because number of teeth will be a complete value, integer value, not decimal or fractional value. This is number of teeth. So is equal to 10. So 10 is the minimum number of teeth on pinion to avoid the interference. 10 is minimum number of teeth on pinion to avoid the interference. If your number of teeth on pinion is less than this minimum number of teeth, interference will occur definitely. But teeth on pinion will greater than this 10. At that time, interference does not occur. So what is TP, teeth on pinion? By already we have find out with the help of that gear ratio formula G. Okay, that G is teeth on pinion is 32. Okay, this 32, but minimum number of teeth to avoid the interference is 10. So 32 is greater than 10. Okay, at that time interference, your answer will be interference does not occur. This is your final answer. Does interference occur or not? No, interference does not occur because teeth on pinion is greater than the minimum number of teeth to avoid the interference. So this condition is satisfied here. Okay, is that clear? So students, this is related with interference. We are closing the topic of interference here. We already solved 3 problems on different condition. Condition number 1, 2, 3. Okay, on these 2 condition, on these three condition, one numerical will compulsory come in the examination. In this, you have to satisfy either condition number 1 or condition number 2 or condition number 3 as per given data. If you have any query regarding the interference, you can write down your queries in comment box. Definitely, I will try to solve your queries regarding the interference. Okay. At the end of this session, the student can understood what is interference, and student can solve the numericals on interference. Okay, thank you so much for attending the session.